welcome to our talk, Building IoT Applications on Google Cloud. I almost said the wrong one. I am Gabe Weiss. I'm a developer advocate for Google on Google Cloud Platform, specializing in IoT. Also on stage with me, we have Callum Barnes. He's a product manager on IoT Core. We have Martin Varela. Sorry, I'm like losing people's names already. Developer advocate on startups. We have Rob Wormald next to her. He is a developer programs engineer on Angular. And lastly, Alicia Williams. She is a developer advocate on G Suite and Google Cloud Platform. So given the range of people, that might give you an idea of what we're talking about today. So now you know who we are. I want to know who you all are. So how many developers, operators, infrastructure, people that are doing the work? Quick show of hands. How many do I have on that? Woohoo! Nice. Welcome. Thank you. Who out there are executives, C-levels, business decision makers? Some of the same hands are going up, so startups, yeah? All right, cool. How many data scientists do we have? Any data scientists? Good. Oh, yeah. Nice. Everyone else, do your arms work? So now that we all know who each other's are, application development. There are a lot of decisions that need to be made before you can start laying down code for an application. I don't want to fool you into thinking that, yes, we're going to be building an end-to-end app today in the 45 minutes we've got, but I don't want to fool you into thinking that you can actually do it on stage. All of these decisions that need to be made, we made a lot of them beforehand. What I do want you to walk away from this talk with are three things. One, understanding what questions you want to be asking yourself about the app that you're going to be building. What are the different parts that are out there? What do we have product-wise in Google Cloud Platform that help you build these IoT applications? Two, that it really is, from a raw code standpoint, easy to build these end-to-end apps. There's a lot of moving parts. There's a lot of products involved. But the actual implementation of each part is actually really easy to do. And we'll be showing you some of that. And thirdly, that what you can put together in this short amount of time is immediately useful. The data that you can get from these simple applications can immediately be introspected, can be looked at, can be used to get ROI on whatever business that you're doing. What I don't want you to take away from this talk is that whatever you put together in that short amount of time is production ready. It's not. Product managers, don't let your eng teams tell you that what they put together in a day for an IoT app is totally ready for release. And eng teams, don't let your product managers tell you that, hey, I saw at Google, they put together an app in an hour. That's enough time, right? It's not. Don't let them tell you that it is. So what's the first thing that you need in order to build an application? Does anyone have any ideas? You can shout it out. If you're shy, it's OK. I'll still give you my answer. But does anyone have an idea? What do you need before you can build an application? An idea. Absolutely. First shot. Nice. So you need an idea. You need to know what you're building towards in order to build an application. I'm going to walk you through what our idea is and how it dictated some of the technology choices that we made in order to build our application. The question that I wanted answered, who up here amongst us is the coolest on stage? Who's the most nervous? Who's anxious being on stage in front of everyone? So there's one really reliable way to detect stress in humans. It's a chemical called cortisol. You can test for it in your blood, and its presence and the amount of it tells you empirically how stressed out you are. I asked the organizers, and they did tell me I'm not allowed to create a biohazard situation on stage, so I couldn't do blood testing. So the next step, what about blood pressure? So blood pressure, how elevated it is, will tell you how stressed you are. Let's think about a blood pressure cuff. It requires that you can detect your heart rate, and you have to be able to apply and release pressure in an even way around your arm. It's totally doable with IoT, but maybe a little ambitious for a 50-minute session. So I kind of got rid of that. So our last option that I fell back to is this thing called the vagal tone impulse. This is your vagus nerve. The vagus nerve is what regulates your heart rate. It's what keeps your heart rate within normal amounts. During times of extreme stress, the vagal tone impulse is suppressed so that your heart rate can skyrocket, so that you can be ready to do whatever you want. The common, you've probably heard about it, is the fight or flight response. So once you're in that mode, your heart rate can go up, even though you don't have any physical need for it. So for example, if you're nervous and you want to tear off stage and run away, you'll get your body flooded with blood so that you can do that faster. So why am I giving you this biology lesson? I could have just said, hey, we want to know who's nervous on stage, and away we go. The reality is I'm vamping a little bit. I wanted to give my team a little bit of a head start so that we could actually show you as we're building what we're doing. So I needed to give them a little bit of time. Also, there's still a monster line outside, so I wanted to make sure that everyone could come in before I'm talking about the technical stuff. So architecture. Here's the architecture in its entirety for the application we are building today. We're going to be creating a simple data-driven application using the IoT devices that Callum is building for us as we speak. For each piece of this architecture, I'm going to talk through the product that we chose, the other options that are available to you in Google Cloud Platform for that piece of the architecture, and then show you a little bit of the implementation that we're working on as we speak. So first, let's chat about this device that we're making. It will be able to measure your heart rate and temperature, and between those two data points, we're going to be able to tell who's really nervous up on stage. Heart rate in particular is going to be our primary indicator. So hardware and IoT. How do you pick what hardware you want to use? Once you picked your hardware, how do you pick what programming language, what software you want to use on that device? There's a problem for those of us that are building out these devices right now. And the reality is who was alive in the 70s? Was the first question. Okay, good. There's at least some of us. I don't feel too old yet. So in the 70s, we had VHS and Betamax. Did anyone own a Betamax player? Yes. Yeah, me too. Next, if you heard about Laserdiscs. Did anyone hear about Laserdiscs? Yeah, all right, so Laserdiscs and DVDs. And now we've got Blu-ray and HD. Hopefully most of the room would know about those. So it's the idea of standards. Each of those technologies eventually resolved into a standard that most of the market could adopt. In IoT, we don't have standards right now. It is a complete Wild West. You could pick any hardware and any software and it would still work. This is just a small sampling of the options that you've got up there today. Sometimes an environmental factor will help you narrow down this choice. So if you're working on the side of a mountain, your options will slim down. You've got communication problems. You've got power consumption issues. That can help dictate what hardware that you're picking. The reality is that for most large-scale IoT installations, you're going to have custom hardware that gets built. You're going to have a microcontroller with custom sensors that really defines the minimum device that you need to accomplish whatever the goal is. Our only real requirement is to read analog sensors. Our heart rate and temperature sensors are analog. They're off the shelf. So we needed something that could speak analog. We also wanted super easy to set up. We've only got 45 minutes to build the entire thing, so I wanted to be sure that whatever we picked would be really easy to set up. The Python libraries have everything we need. Everything that we need to do this end-to-end, Python has libraries for them, and it was out of the box. We wanted something that could run Python. So our device is an Arduino, so that we could read the analog devices really easily, connected over serial to a Raspberry Pi, which is super easy to connect and runs Python. Production, obviously, for most IoT, that's not what you're going to end up using. It's not cost effective, but for our purposes, just to highlight the technology, it's going to work great. So let's take a look, if we could, at the device that Callum's building. Could we switch to demo 1, please? What we're seeing here is we can see the Arduino chip right here on top of our device, and inside this case is the Raspberry Pi. The two sensors that we're seeing now is the heart rate sensor, which is on a little ear clip, and then we've got the temperature sensor, this little probe guy. So I'm going to have that temperature sensor in my mouth, and we'll see how accurate a reading we can get as I'm trying to give a talk with a sensor in my mouth. So before we check out the software that Callum's got on the device running it, can we switch back to slides now, please? I want to talk to us a little bit about ingesting our data. Yay. So before we can ingest data, there's something I want to talk about, and it's going to be the hill that I die upon for IoT. And it's a question. What does the S in IoT stand for? Security. It's funny because there's no S in IoT. Get that? So there's a couple of anecdotes I want to tell about security that kind of highlights why you should care. A couple years ago, a bunch of you may remember that the whole internet, large swaths of it went down for hours. There was something called the Mirai botnet attack. And what Mirai software did is it scanned the whole internet for unsecured IoT devices. It found 11.3 million of them. It launched a massive botnet attack against DYN, the domain services for the whole internet, and it took the internet down for a bunch of hours. So that's the macro view. All of those devices could take down something like the internet for a while. Micro view. Last year, there was a single temperature sensor in a fish tank in a casino, and it was connected to an internal machine so it could regulate the temperature of that fish tank. And an enterprising young Finnish hacker found that temperature sensor, hacked it, got access to the internal machine, and pulled out 10 gigabytes of high roller data from that casino. They lost millions of dollars and lost face to all of those high rollers. So this is why you need to care about security. The macro view with the Mirai botnet attack and the micro with this Finnish hacker taking all of the casino data. I could talk for a long time about how you can countermeasure this, how you can secure your devices. I'm not going to. Because on Thursday at 10:20, there is security and IoT talk. It's being done by a colleague and a partner of ours that is a really good talk. So if you want to learn and go into depth on security and IoT, go to their talk, because it's going to be really good. For ingestion, then, back to that, this is why I picked Cloud IoT Core as our choice for that. Cloud IoT Core is the Google Cloud Platform gateway for devices to send their telemetry data up into the cloud. It handles things like device authorization, that security piece I'm talking about. Management, it allows you to configure your devices from the cloud. You can send messages back down to your devices. It allows you to have your devices report their state, so you can check the health of your fleet from the cloud without having to talk directly to your device. It's a managed service. It's just an endpoint that you talk to. So you configure your devices to talk to a URL. There's no client libraries. So if space is an issue, if you're on a microcontroller with only 200K of space, it's at a premium. You don't want to have client libraries. IoT Core lets you handle that. All right. So before I still show you the code that Callum is running on the device, I want to talk to you about what the other options that you could do. Instead of talking to IoT Core, what are some other possibilities that you could do? You could leave IoT Core and talk directly to the event queue system that backs it, Cloud PubSub. So you could cut out IoT Core. I left the management block on here on purpose, because if you skip IoT Core, what you're left with is having to manage your devices. You have to authorize them. You have to deal with them if one of them gets compromised, and you have to shut it off. You have to now manage all of that yourself in software. Another option, you could skip all of that and talk directly to your data store. Now, on top of having to manage all your devices, you also have this problem where, what if your write to your data store fails? Someone kicks a cable or sunspots or just a plain networking problem. Now, all of that retry code to get your data into your data warehouse, instead of already having your data in the cloud in something safe like PubSub, now you have to redo it from your device, which for devices, network is your battery killer. If you have to keep running network from your device, that's going to run you out of batteries and causes this cascade of failure. So if you skip all of this and talking directly to data store, your devices or an edge machine is now responsible for doing all of that retry logic. So again, this is why we went with IoT Core. It's the way to go. So we're still almost ready to talk to that code. No, I lied. We actually are ready to talk to the code from Callum now. So if now we could switch to the demo 1. Awesome. And Callum is actually going to take us through the code that he wrote on the device.
Thanks, Gabe. So what I've done, since we only have 45 minutes here, is basically copied most of the code from the IoT Core Python tutorial written by another great dev advocate, Gus Class. And what that does for us is make two things really easy. Connecting and authenticating with IoT Core, and then sending messages to IoT Core over MQTT. And those are the messages that are going to contain the data we're going to build our application with. So you can see in this Python sample that comes straight from the website, we have a create jot function. If you go to that security talk Gabe mentioned on Thursday, you'll find out even more about how IoT authentication works. But we create a special jot authentication token based on a private key on the device. And this function makes it really, really easy to generate that and send it to IoT Core. And then the rest of what we have is basically boilerplate PAHO MQTT code to connect to the IoT Core MQTT front ends. All I've added in here in the last few minutes is some configuration information about the specific project that Martin set up when we got started. And then a little bit of code to talk to the serial input from the Arduino and toggle the LED when we get over some limits that we'll talk about later. So all of this has been pretty easy to write because I was able to leverage the samples that we have on the IoT Core documentation website. Sweet. Thanks, Gabe.
Thank you, Cal. So we've now covered kind of the why and the how of devices and ingestion into the cloud, getting it up there. Next up, we need to get all of that data from Cloud PubSub, where IoT Core puts it, into our data storage. We've decided to use Google Cloud Functions to do that. Cloud Functions are serverless methods. They can be called with either an HTTP GET or POST call, or triggered from something that happens in Google Cloud Platform. For us, we're using PubSub as our trigger. So any message that comes into Cloud PubSub will fire off this function. Since I know Martin's probably already getting bored since he finished this like in the first 2 minutes, we're going to cut over to Martin, and we're going to show some of the code that he did. So we need to switch to demo 2, please.
Yep, that's it.
Awesome.
Thank you, Gabe. So I just finished 5 minutes ago. I didn't have that much time. Deploying this function that I call telemetry to Firestore. Again, as Gabe said, what this is doing, this function is subscribed to a PubSub topic, so that every time one of the devices that we're building sends telemetry to IoT Core, that sends a PubSub message and triggers a new execution or a new instance of this function. Let's take a look at the code here. As you can see, this is written in JavaScript, and it's running on a Node.js version 6 environment. At the top, I'm just calling and importing the library that I'm using to write to Firebase, to Firestore, and initializing the app. Because we are running on this managed environment, we don't need to do any authentication. That's handled for us. And then the about 20 lines that are next is the actual function. The function expects an event from PubSub. I will check if it has data. Otherwise, I'm going to throw an error. Then I'm going to base64 decode the payload, parse it into a JavaScript object, so it's easier to grab the attributes. And then this is where I write to the DB. How Firebase works, or how Firestore works, is that it stores a collection of documents. And each document can have a bunch of different attributes. In this case, we're sending the timestamp, temperature, and BPM, as you can see here. And this is the path to the where I want to write the documents. And then it's just whether it fails or not, I'm going to console log it just for reference. And that's pretty much it.
Sweet. Thanks, Martin. So this is the glue that joins our event messaging system as the telemetry is coming in to our warehouse. Can we switch back to slides again, please? So let's chat a bit about what the other options if you didn't want to use Cloud Functions. And there's a reason you might not want to use Cloud Functions. For IoT, there's really 3 really good options in Google Cloud Platform for this. Cloud Functions, Cloud Data Flow, and Cloud Data Proc. Cloud Functions I've already covered. They're serverless. It's a low barrier to entry because it's JavaScript, so it's easy to stand up and get going. And it fires once per message coming in. That once per message coming in, that's the catch. That's the reason you might not want to be using Cloud Functions. If you're managing a fleet of 1 million devices, and those 1 million devices are sending a message once a second, that's now a million firings per second of this Cloud Function. Part of their cost is number of invocations. So if you've got a system that has a very high throughput, that's why you might want to look at Cloud Data Flow and Data Proc. So Cloud Data Flow and Data Proc are both managed service. They're very similar in what they can do. Data Flow is our managed service for transforming incoming batched or streaming data. It can do pipeline development with the Apache Beam SDK, and it handles very high throughput. That's what it's designed to do. Data Proc is very similar to that. It also handles a very high throughput. It does a lot of the same transforms. It's hosted Apache Hadoop and Apache Spark. So really, why would you pick one versus the other is the platform that you're familiar with. So how do you know when you should use one versus the other? The answer is it really depends. If you're not doing anything but shuttling data from point A to point B, you're just taking it from the event system and pushing it into your data store, it really doesn't matter that much. They're both going to perform really well for you. The invocations per second is what I'm talking about. So if you've got very high throughput, that's where you would want to switch over to Dataflow or Dataproc. For me, the general rule of thumb, always prototype with Cloud Functions. Get your entire end-to-end working, find out what you don't know, get everything functional, and then when the cost starts to become an issue, cut over to Dataflow or Dataproc. All right, so we've got ingest, we've got devices, we've got pipeline. Next up, we're on to storage. Everyone still doing OK out there? Yeah, so I know I'm throwing a lot of stuff at you very quickly. I wish I could tell you it's going to get better. It's not. I'm going to continue to throw a lot of stuff at you very quickly. Because next up is storage, and there's a lot to cover. So for our application, we picked Cloud Firestore. It's a NoSQL database. It's very low latency and low response time. It's perfect for doing the real-time visualization that I talked about at the beginning, because built into it in native mode, it's got a push mechanism, an update mechanism, where anytime you get a data change, it fires a callback. It's one of the unique pieces of Firestore in our kind of storage options, which is why we've decided to pick it today. It's also really easy to stand up. So what are some options if you didn't want to use Cloud Firestore? We have a flowchart for that. No need to memorize this. It's actually on our website. It's at cloud.google.com/storage-options. Memorize that one. So this flowchart is not intended to give you the be-all, end-all option for your storage. There's a lot of edge cases that are little gotchas in here. But this flowchart will help you things like, is your data structured or not? Are you doing analytics or real-time analysis? Do you need mobile SDKs? That's what this flowchart will help you with. Cost is the last piece. The flowchart won't help you with cost. But it's so dependent on your individual applications. We have tools online that you can put in things like general throughput, amount of storage you need. The online tools will help guide you through what your rough monthly cost will be depending on the storage that you pick. So there's too many on that flowchart for us to go through all of them in detail, but I want to highlight just a few. And to speak to IoT, there's usually two different things with storage that you're wanting to care about for an IoT application. There's a real-time analysis if you're doing things like fault detection or automatic inference. You want to get a low latency response, or you're doing really heavy analytics. So IoT often is just a vehicle to get data into the cloud to run analysis on. Those are the two things. And so I put them on this graph so that I can put our different products on it to give you just a ballpark finger in the wind what the different products are good at. So first up, Firestore. I've already pretty much covered it. It's very, very good at real time. And it's not the worst in analytics, but it is a NoSQL database. If you're not familiar with SQL versus NoSQL, NoSQL is not the best at doing really complicated queries because you have to scan a whole bunch of rows and then parse for what you want within it since it's unstructured data. SQL is much better for running that kind of query where you can really get at exactly what you want in the query. So that's why Firestore is where it is. Next, we have Cloud Bigtable. Bigtable is the speediest of our speedy NoSQL databases. It's incredibly fast, and it scales up to really massive amounts of data. Petabytes of data are not a problem for Bigtable. The reason it's so far on the analytics left-hand side because it's terrible at it. The way that it is so fast is that it is incredibly bare bones. Anything that you want on top of it, you have to build. There's no tooling built into it. So it's a kind of a blank canvas NoSQL database. We would never have done it for today because there's way too much tooling you'd have to build up. Next up is Cloud Data Store. It's much more of kind of an out-of-the-box NoSQL solution. It's got a bunch of tooling on top of it. It's got a very well-developed querying API, and it's easy to understand and use. In function, it's very similar to Cloud Firestore. The tipping point for us with Firestore is why it's a little bit better in the real time is that update mechanism, that push mechanism. We didn't want to have to build something to do push to our real-time front end, so that's why we picked it over Data Store. Next, we have Cloud SQL, our SQL option. It's hosted MySQL or Postgres. If you need a SQL database, this is the option for it. It's very low latency. It's better on the analytics scale because it's SQL, so it can do more complex queries. There is a gotcha. And SQL, you should know about it, which is SQL cannot horizontally scale. It can only vertically scale. So if all of your data fits happily on a single machine, awesome. Use Cloud SQL if all of your data will. Now for today, I could have used Cloud SQL. There's no way our sensors today are going to overwhelm a single box. But I didn't want to highlight a solution that for most IoT applications aren't going to be doable. Most IoT is going to produce enough data that it would overwhelm SQL right away. And lastly, way down in the corner, we have BigQuery. Does anyone know about BigQuery already? Yeah, a bunch of you do. If you don't, get familiar. If you're doing any kind of data analytics, BigQuery is what you want to use. Hands down, no question, you should be using it. And if you're not doing analytics as part of your IoT application, I would ask you, why are you not doing analytics as part of your IoT application? Because it's data, and a lot of it, and you can get really cool stuff out of it. So BigQuery is, it's unique in the offering in that you use SQL queries against a NoSQL backend. And it's amazing, which means for analytics, it is the best of both worlds. You can use SQL statements, and it horizontally scales. It also will scale up to petabytes of data. And you can run queries performant for the size against that data. Now, having said that, it is performant, but it's not real time. I would never, ever build a real-time application on top of BigQuery because it will be terrible at it. If I had more time or in the session today, and in a perfect world, you would want something like this, where that cloud function that's pulling your data out of PubSub and putting it into your real-time analysis data store like Firestore, you would also duplicate the data over into your data warehouse like BigQuery. That way you really get the best of both worlds for the cost of some storage, which is cheap. You get the real-time analysis, you get all of the low latency of Firestore, and you get the power and the analytics of BigQuery behind it. So I've talked a little bit about latency, real-time processing. Something that I haven't talked about yet, which I can't, is computing on the edge. That's kind of all the buzzword right now, right? You want to compute on the edge, be on the edge. I could spend an entire talk discussing cloud versus the edge versus hybrid versus fog, although fog really is just edge. It's just another buzzword. that whole talk is going to take up all of the time. Broadly speaking, kind of a finger in the wind. Storage, do it in the cloud. If you need real-time compute, low latency, do it on the edge. You want to do data visualization, probably safe doing it in the cloud. Safety checks on a nuclear power plant, please do it on the edge. Don't do that on the cloud. So we've covered all of our headless stuff now. We've gone from device up into IoT Core bridged into Cloud PubSub, Cloud Functions pulling off of PubSub, dumping it into Firestore. All of the no visual stuff. So we still have not answered my question of who's nervous. So let's see if we can answer those questions. I could spend a really long time talking about all of the front-end possibilities for an IoT application. This is like the tiniest of samples up there. I do not have a mountain of time to talk about front ends of all of what your options are. So I'm going to talk about the two options that we have picked. So we could have just done one front end, but I wanted to see how many people we could pack up on stage here. I asked if we could do 4. They told me I didn't have enough pedestals to do 4, so we settled on 2. It was kind of a negotiation back and forth. So my goals for showing you front ends to an IoT application are twofold. I wanted to show you real-time visualization and time slice visualization of data, and I wanted to show off the front end's ability to modify metadata around a device. And I talked about earlier, IoT Core has the ability to send messages back down to device and configure them. And we're going to try that. Hopefully the demo gods are kind. So first, to highlight the real-time display piece, I wanted to talk about Angular. That's what we picked. How many of you know what Angular is? Yeah, all right. So Angular is our batteries included framework for JavaScript. It has components to do everything that you would need to do in a web app. Routing, animation, rendering, forms, IL8N support, integrated testing, all of those things you would want to have in a web app, we've got in Angular. So at this point, I think we're going to try and get me loaded up with a device. I think I'm ready. Rob, are you ready to show off your piece? All right. So normally you wouldn't ever do this in production. We would have unit tests. We would have integrated tests. We wouldn't be using a device that we just built on stage. Here, we just pray the demo gods and see how it goes. All right, so I'm going to hold this in this hand. And we're going to slide finger. All right, can we switch to, what do you want? Demo 2 and input 3. Yeah, OK, so let's see. I'm shaking like a leaf, but I think I have decent connection. All right, so what we're seeing on screen now is the iteration of the devices. All right, so we've clicked in Gabe's device. Hey, where'd it go? Gabe, where's my device? There we go. Hey, Alicia, could we change my name to something snazzier? Gabe's device is kind of boring. I am now the destroyer of worlds. Thank you, Alicia. So, OK, so if we click into that and we're seeing now these latest readings, we might have some garbage here because when the heartbeat sensor isn't attached to a finger, it just sends kind of random noise on analog. So it looks like we're kind of starting to normalize a little bit on device here. I'm trying to make sure that I've got it. Yeah, OK. I wanted to highlight 2 things that just happened. So first, the Angular app that's on stage now is reading from Firestore in real time. Any of the sensors that are getting pushed once a second up into the cloud are being, yeah, I'm still going, are being shown here. So you see, you know, my BPM's 107. Oh, I'm excited. And 2, Alicia made a change to my device in Firestore on her front end, and it was almost instantly recognized in the Angular app and updated live. So Rob, I do like what we've done here, but it's going to be hard to tell side by side, you know, who's actually the most nervous. Can we get all 5 of us in a graph? Sure, I can give you a minute. While he's doing that, I'm going to talk about our second front app with what Alicia's been working on. Can we switch to Alicia's laptop? So while we're doing this, once we're hooked up, Martin and Callum, you guys are getting hooked up. Rob, when you're done with the graph, go ahead and you get hooked up too. Hopefully now we've got Alicia's screen that's going to come up soon. OK, so while we're getting her set up here, the second front that we're doing is going to be Google Sheets, G Suite, backed by AppScript. So do we know about AppScript? A couple do? Good. That's why I wanted to do this talk, so we could highlight the fact that we've got AppScript going on. So what we see on screen now is her screen, and it's showing the metadata configuration page. So this is where she changed my name over to that Destroyer of Worlds value. So I know a lot of you are thinking like, yeah, and she changed a value. It's happening in real time, and we just built it. It's going from one front end through the cloud and updating in a second front end. The next thing I want to show off is the next tab, is the ability to configure our devices in some fashion. And this is where we really see how this is going to go. So right now, on our devices, we have a value called the heartbeat threshold. So if my heartbeat goes above that threshold, the LED that's on this device is going to light up. Right now, it's set to 999 because we knew that when the things aren't connected, they send really high values, and we didn't want it to accidentally go off early. So now, let's go ahead and set the threshold down to 120, which both I should be able to hit and I shouldn't hit at the moment. So what I'm going to try and do here is see if I can get it to trigger and get this light to go on. Hang in there. I am really out of shape. All right, so my heart rate, I love the music. I love the music choice, guys. All right, so now we get to the play of the game of how long does it take Gabe's heart rate to go back below 120? Probably a while. So how this works from Sheets, we've got a single cell that when she enters the threshold into it, it iterates over all of our devices and fires off to another cloud function. It's a second cloud function that Martin wrote, and all it does is it calls the IoT admin SDK and sends that configuration message back down to all of our devices to update them. Yes, I know I'm out of shape. So it does, the app script is calling HTTP to call into that second cloud function. So it's not a trigger, it's actually using that first method that I talked about with the cloud functions. The last piece that I wanted to show off, and let's switch to this, yeah, there we go, is this is the time slice data I was talking about. So she is fetching the data from the last 60 seconds or so of me. So that big, the jaggy spike, that's me running around the room, because, ouch. So with Sheets, you get up to 2 million cells of data. So what Sheets is really good at, pulling in large amounts of data. So down the graphing is going to be similar to the Angular, but I wanted to highlight it's the time slice, not the real time that the Angular is. So that's what we want to highlight for Sheets, is that you're looking at historical data, not live. Down below now is we've got some conditional formatting. So anytime my heart rate is above the set threshold, it's being conditionally formatted in that red. So it's a quick way to get just a quick and dirty look at your data by doing some analysis in semi-real time so that you can see what's happening. So now I would like to go through the app script code, if Alicia would be so kind.
Sure. So I think some of you raised your hands, but for those of you that don't know, AppScript is a scripting language based on JavaScript with a bunch of enhancements for G Suite to be able to automate between different Google products and services. So the first line of code I want to show you is just where I query Firestore. So I'm using a library that connects AppScript to Firestore, and I'm querying for a specific device. I had Gabe's device up there, the most recent 60 measurements. So then I'm taking that returned list of measurements, and I'm appending a new row to the spreadsheet for each measurement. And kind of in between there, I wanted to know what time slice it really represented because they are sent about once a second. But I'm pulling the first and last measurement and just notating that start and stop time. And then finally, I'm adding some conditional formatting down here, creating a conditional formatting rule so that any BPM value over the current threshold is made into a background color of red.
Awesome. Thank you, Alicia. So now we've seen how AppScript does it, pulling and showing the data. Rob, talk to me. How are we doing on graphs?
Good to go.
All right. So let's switch back over to Rob. And we will see, look, hey, it's our heart rates all on screen. So each of us has our own color. And now I want to know, Alicia, go ahead and get hooked up to your device. So she's in yellow. That's that like squiggly way up high. That's the garbage data that I was talking about. So once she gets properly hooked, it's already dipping down. So what color was I? I was blue. I want to be the coolest. I'm not the coolest. Wow, Alicia, are you still alive? I'm blue. I get to be the coolest cucumber on stage. Check that out. We're all pretty close, though. So the question has been answered. I get to be, and I'm out of shape. I just ran around the room. What's wrong with you people? So Rob, now that we've kind of seen it, let's go into your code. And so we've seen AppScript do the data pulling. Now I want to show you off the Angular app doing the data pulling. So go ahead, Rob.
OK. Switch over to my editor. So I'm using Angular, and obviously I use the Angular CLI to go ahead and scaffold a project. So it's set up tooling and building and all that stuff that's really hard about JavaScript. The first thing we looked at was our devices screen, and that's just a couple of screens. So I've got a very simple device list component, a little bit of HTML with some Angular bindings. We're just iterating over devices and rendering some data. One of the nice things about Angular is that we have a really, really good relationship with Firebase. So we have a really nice built-in Firebase Angular library, Angular Firestore. So it takes one line of code to talk to Firestore, extract that data, and then I get a real-time display of that. We go a little more in depth into our detail view. You can see we're doing the same thing. We're just using our built-in Angular Fire service. We are just extracting data, getting some routing parameters, and just streaming the last measurements off of the device. So that's kind of basic Angular templating. That works pretty simply. For the pulse graph, because that's a lot more complicated, we're using D3, which is an awesome graphing library that's open source. Again, we're just talking to Firebase, getting that device data coming out. I won't bore you with all the math that we're going on in here, but basically we're taking the BPM and the timestamp and scaling them so they fit in the screen, and just rendering a line across the screen. So there you go.
Sweet. Thank you, Rob. So let's go back to slides. Yep. All right. So to recap, since the keynote went a little long, so I'm trying to wrap us up so we get us all back on schedule. We built an entire app on stage in front of you in 35 minutes that we went to from custom devices. I'm still over, really? Custom devices up and through IoT Core, bridged into Cloud PubSub, Cloud Functions to pull from PubSub into Cloud Firestore, Firestore firing real-time updates to power our Angular app, Google Sheets, powered by AppScript, to pull to show us time slice data, configure our devices with an LED that will not shut off for me, and what else? And a configured metadata in Firestore as well. That is our end-to-end simple data application all the way through. Thank you, team, for making all of that happen. Thank you for coming.